Hi everyone, today I'm gonna teach you how to convert from binary to other number systems. So, first of all, binary means 2. And in this system we only have 0 or 1 to represent any number. So in binary system we have what we call bits, and every bit we fill it with 0 or 1. And based on some conditions we're gonna decide whether to fill it with 0 or 1. The second system is decimal, and decimal means 10. In this system we only have from 0 up to 9 to represent any number. And octal means 8, so we have 8 numbers to represent like any other numbers, starting from 0 up to 7. And hexadecimal means 16, and we have from 0 up to 9, just like the decimal, but we have in this system extra 6 numbers because there is no numbers to be represented, so they deal like in this system you're gonna deal with letters A, B, C, D, E, and finally F. So here we have this one in hexadecimal, and what is equivalent to it in decimal system? A is equivalent to 10, B is equivalent to 11, C is equivalent to 12, D is equivalent to 13, E is equivalent to 14, and this one is 14, and F is equivalent to 15. So now I'm gonna teach you how to convert from binary to decimal. I just want to tell you that you should keep in mind that whenever you're dealing with binary numbers, you should have this picture in your mind that for the least significant bit, this one, it's always 2 to the power 0, and you keep incrementing the power every time. And the last bit, which is the most significant bit, has the value of 2 to the power. Let's assume that I told you to represent a particular number in binary using a specific number of bits. So if we assume that the number of bits equals n, so n equals number of bits, so this one will be n minus 1. So always we have the most significant bit as n, 2 to the power n minus 1. And here we keep incrementing it, so this one will be the power, 2 to the power 1, until we reach our most significant bit. So let's have an example so you can understand how to convert from binary to decimal. As you can see here, we have this binary number. This is a binary number, so we write 2 here. And now we're gonna start converting from binary to decimal. The first bit will have the value of 2 to the power 0. The second one, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power 6, 2 to the power 7, 2 to the power 8, and 2 to the power 9, as we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 bits. So the most significant bit that we're going to have in this number is 2 to the power 10 minus 1, which is 2 to the power 9. So now we're gonna add these numbers together only if it had 1 in front of it. If it has like 0, just ignore it. So this one will be ignored, this one will be ignored, and this one will be ignored. So here we're gonna take 2 to the power 1 and 2 to the power 2 and 2 to the power 3, 2 to the power 5, 2 2 to the power 6, 2 to the power 7, and 2 to the power 9. We add all these numbers together. Just give me 1 minute. So we have 750 is our decimal number, which is equivalent to this binary number. So at the end, we're gonna write that 1011101110 is equal to 750 in decimal. So now let's move to the other one, which is converting a binary number to an octal. So octal means 8, and how can we represent 8 in a binary number? Actually, we need like 8. We're gonna find a power for 2 that if we raise it for like 2 to the power something will give us 8. So for this one, the power will be 3. So we only need 3 bits to represent any digit in an octal number. And now I'm gonna give you an example so things will be much better. Here we're gonna divide this binary number, each 3 bits together. Our 3 bits are together here, and then these 3, and here we actually have only 2, but you can put a 0 here and take these 3 together. The 0 won't change anything actually. So we're gonna do the same. We add the numbers together, but only for 3 bits. So this one will be 2 to the power 0, 2 to the power 1, 2 to the power 2, and the bit that has the value of 0, just ignore it. So this one will be ignored. So we're only gonna add these together. 2 to the power 0 plus 2 to the power 1. We're gonna get 2 plus 1, because anything to power 0 is 1. So this one will be 3. Just we're gonna write here 3. And then this one, 2 to the power 0, 2 to the power 1, 2 to the power 2. We're gonna ignore these 2. So our answer will be 4. So we have here 4. Then this one is the same as the first one, as well as this. So we have 3, 3. So the binary number, which is 110111100011 binary, is equivalent to 3343 in octal. The last thing is how to convert from binary to hexadecimal. So the idea of hexadecimal, like converting from binary to hexadecimal, is really simple and similar to what we did in the octal. So hexadecimal means 16. So you should think about a number that if you had it for the 2, like 2 to the power something, will give us 16. So this number will be 4. So we're only gonna take each 4 bits together to represent any digit in an hexadecimal number. So let's have an example. Convert the following number from binary to hexadecimal. We're going to divide this number, each 4 bits together, and now we're going to do the same as the previous one. 2 to the power 0, 2 to the power 1, 2 to the power 2, and 2 to the power 3. Ignore any bits with zeros, so this one will be ignored. Gonna take 2 to the power 0 plus 2 to the power 2 plus 2 to the power 3. This one will give us 1 plus 4 plus 8. and then we'll end up with 13. 13 means D. So you'll be memorizing it, so it will, like, you won't memorize them, because by practicing it will be easy to just figure it out directly. A is 10, B is 11, C is 12, D is 13, E is 14, and F is 15. So here we have at the least significant, like here for the least significant number or side or digit, we have D. And then for this one will be 2 to the power 0, 2 to the power 1, 2 to the power 2, and 2 to the power 3. Just ignore anyone with zeros, so this one will be ignored and this one will be ignored. 2 to the power 3 plus 2 to the power 1 will give us 10. This one is equivalent to A in hexadecimal. And then we have 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3. Ignore these two. So we're gonna add 2 to the power 1 plus 2 to the power 0, which is 3. So 0, 0, 1, 1, 1, 0, 1, 0, 1, 1, 0, 1. Binary is equivalent to 3AD in hexadecimal. So that's the end of this video, and if you have any question, just feel free to ask, and thanks for watching.